Hello, welcome to the video. In this lesson, we're looking at 6.5, where we're going to be solving exponential equations. So essentially what happens is our variables are going to be in the exponential portion of our equation, and we're going to have to be able to solve those things. The way that we could solve them is the easiest thing to do is make sure that we have the same base on both sides of the equation. So over here, if you notice how both of these have a base of 2. One is 2 to the x power, and the other one is 2 to the 5th power. Once you've established that both sides of the equation, both sides of the equal sign are the same, you can eliminate the base and just look at the exponent value from there. So I have x over here, I have 5 over here. That means that 5 is going to be equal to x. So if any of the problems have the same base values, it is going to be relatively straightforward in solving each of those particular equations. If they don't, we have to kind of manipulate one side or even both sides to make it look like the same thing. And there will be some situations where that occurs, but I'll show you what that looks like when that comes. So what we have here is we have 3 different examples, but they all have the same base on each side. For example A, both of them have a base of 3. Since they both have a base of 3, now I can just turn to the exponents. The exponents is just going to be x plus 1 is equal to 5. Subtracting 1 from both sides, x is going to be 4. So 4 is my value for x. Looking at B, I have same base values of 6. Since I have the same base, this is, remember, this is 6 to the 1st power, so this is going to be 1 is equal to 2x minus 3. Add 3 to both sides, so now I got 4 is equal to 2x divided by 2. X will now be equal to 2. Over here, I have same base values. Now I just look at the exponents. I got 3x is equal to 2x plus 3. I subtract 2x to both sides, I got x is now equal to 3. Like I said, relatively straightforward when you have the same base values. Where it becomes a little bit more tricky is when they don't appear to have the same base values initially. So for these particular ones, we have exponential equations, but the problem is we don't have the same base. We have 5 and we have 125, not the same. 4 and 2, not the same. 9 and 27, not the same. So what we have to do now is we have to kind of manipulate it in a way to make it look like the same base. 125. Can I make it look like 5? The answer is yes, because I have 5 to the x power here, but another way of writing 125 is 5 to the 3rd power. Now I had the same base of 5. Now I can say, oh, now this is just x equals 3. And I get my result. I look over here, I have 4 and I have 2. They're not the same, but what can I do with 4? I can make it look like 2 by saying, oh, this is now 2 squared, and now it is raised to the x power. And this is now going to be equal to 2 raised to the x minus 3 power. Well, this is like, I remember that power of power rule. This is now going to be 2 to the 2x power is equal to 2 to the x minus 3 power. Looking at this, this is now the same base. I can now say this is now 2x is equal to x minus 3. I subtract x to both sides. X is now going to be equal to a negative 3. And I would encourage you to, you can check these out to the original uh, equations to see if they work. I have 9, I have 27. Now, this one here is a little bit different than A and B. I only had to change one side of the equal sign for examples A and examples B to get my result. But when I look at 27, there's nothing I can manipulate it fraction, exponent wise to make it 9. So what I can put is I can make 3, but I can do 3 for both. So what I'm going to do here is with the 9, I'm going to say, oh, this is now 3 squared raised to the x plus 1 power. And it's going to be equal to 3 cubed raised to the x power. Now, what you have to take into account here is this gets multiplied this, but you have to distribute. It's just like the distributive property. So this now turns into 3 to the 2x plus 4 power is equal to the 3 to the 3x power. So remember, you got to distribute that. Now I have the same base. Now I can write it as 2x plus 4 is equal to 3x. Subtracting 2x to both sides, 4 is equal to x. Looking at this one, I have 1/2 and I have 4. So what I want to try to do is I want to make this one, first off, I want to make this one not a fraction. In order to get this not to be a fraction, I'm going to rewrite this as 2 to the negative 1 power raised to x is equal to 4. So now I have 2 to the negative x power is equal to 4. Now that I have a base of 2 over here, I can manipulate 4 to make 2. So now I can say this is 2 to the negative x power is equal to 2 squared. So now I can say, okay, I got same base. Now negative x is equal to 2, which means x is equal to negative 2. Over here, I have 4x to the plus 1. I have 1 over 64. So again, like the first thing I want to do is I want to make that not a fraction. So now I have 4 to the x plus 1 power is equal to 64 to the negative 1. Well, how can I get 64 into 4? So it's what, 4 to the third. So I can say this is 4 raised to the x plus 1 is equal to 4 to the third, and this is to the negative 1. Now, power to power rule, this is 4x plus 1 is equal to 4 to the negative 3. Now I have the same base of 4. Now I can say this is x plus 1 is equal to a negative 3. Subtracting 1 from both sides, x is going to be equal to negative 4. And that is being able to solve exponential equations. Hope this helps. Until next time.